Good evening, students. In today's NTC class, we are going to discuss about the chapter from class 9, Matter in Our Surrounding. I know that I told you earlier that we are going to discuss about acid-base salt, but since that chapter we have not started in a regular course, so we will refresh this chapter. This is also one of the important chapter from which some application-based questions are being or coming in NTC first level. So I'll just give some key points regarding this chapter, because this chapter already you read in class 9, and after giving these key points I'll give one notes on that key points and also provide some questions that you are going to solve. Okay, so first of all we should know what is matter. Matter, anything that occupies space and has mass and can be perceived by our physical sense, can be considered as matter. So in that case, the matter is made up of particles, consists of particles. It is not continuous, rather it is particles. We can come to the end part, that is the particle nature of the matter. And so the different characteristics of matter, that is, the particles of matter are very, very small. They are so small that is cannot be imagined. They are beyond our expectation. So just to recall your addition of a drop of Dettol into the water, and you can have number of times. If you dilute it, you can still smell the smell of the Dettol in your 4th or 5th diluted glass. And the particles of matter are always moving, that is, they possess kinetic energy. If the kinetic energy, this kinetic energy will become more if the temperature is more. Okay, then particles of matter attract each other. So the force of attraction between the particles can be considered as cohesive force or adhesive force. Cohesive force means the substance, the particles of the same substance that attracts, that is the cohesive force. If the particles of different substance that is attached, that is adhesive force. For example, if I am going to write it in this marker on this board, the particles of this ink marker, they do attract, that is cohesive, but the particles that stick to the board, that can be considered as an adhesive force for which they are sticking it. Then particles of matter have space between them. So that can be understood when we are adding some salt or sugar into water and getting dissolved, but the volume does not rise. The level of the water does not rise because they have the space. That's why they occupy the space between them. And then we have usually the three different states: solid, liquid and gas, which they vary in property. So in that key point notes I have given the difference between the solid state, liquid state, gaseous state. Like you do have solid have fixed shape and size, and they have the particular volume. Liquids do have volume, but they do not have fixed shape. Gases have neither fixed volume nor fixed shape, because the particles are in random motion, always moving, and they also in an enclosed container, they move and strike along on the walls of the container, exerting pressure in that. And the interparticle space, interparticle force of attraction, in that way also they are different. And regarding the property called fluidity, that is the tendency to flow, liquid and gases have a tendency to flow, but solid they do not have. So fluidity is the tendency to flow, and viscosity is the resistance to flow. So that is the difference. One you can be asked for in some exams regarding viscosity and fluidity. And usually the three states differ in that way, but apart from that, we do have a state called plasma state, where the highly ionized gases are there, the super energetic particles are there. Similarly, another fifth state of matter which is also there, called Bose-Einstein condensate. So there is not much of the things are given, but you can say some gases are extremely of low density that can be remained. So they come to the state called Bose-Einstein condensate. Then we will come to the interconversion states of matter. As you can see here, we do have solid, liquid, gas, and the major factor that affects is the change in temperature and pressure. And the process that initiated, the like solid to liquid, you can say melting, liquid to solid is called freezing. Similarly, liquid to gas, vaporization, and gas to liquid is condensation. Similarly, solid can directly also changes to gas in some cases, like the change of ammonium chloride solid. When heated, it forms a sublimate, and that process is called sublimation. Similarly, the particles of those ammonium chloride vapor can be condenses that can be again deposited to form solid. So that process can be called as deposition or sublimation. So iodine is another substance which is a sublimable solid. Your dry ice means your solid carbon dioxide, you can say. Carbon dioxide when undergo under pressure and high pressure, then at lowering the temperature, then it gets converted directly to solid. And then we have like your after the interconversion of states, there are some other factors like your specific heat. And also, yes, before that, let me tell you about the latent heat of fusion. That is the amount of heat energy required to convert a unit mass of solid to liquid at a fixed temperature. That means suppose you will take a mass of ice and start heating it. So this ice changes to liquid water, and during the process of melting, the temperature remains constant. And this, but the heat is supplied. The heat energy utilized is used in changing the physical state of the substance. So there is, on an average, the kinetic energy of the particles remain constant. That's why temperature does not rise. The heat is utilized in changing the physical state of the substance. Similarly, we do have latent heat of vaporization. That is the amount of heat required to change the unit mass of liquid to its gaseous state at a fixed temperature, that is at its boiling point, and without the rise in temperature. That is if the water is taken and it is heated to its boiling point, during the process of boiling, when the liquid water changes to steam, you will find that there is no rise in temperature. So that the heat, that is hidden heat, the latent heat, and it is used in converting the liquid to vapor. Okay, so that is another part. Then one more thing you need to remember, that is your specific heat. That is the amount of heat required to convert a unit mass of a substance, okay, to raise the temperature of a unit mass of a substance to 1 degree centigrade. That is your specific heat. So the unit may be taken as joule into kg per degree centigrade. And there is also the temperature conversion is there, that is your degree centigrade to Kelvin. So these are things, the usual things you know. If you are going to convert the Celsius scale to your Kelvin scale, then just add 273. And if you want to convert the your Kelvin scale to Celsius scale, then subtract 273. But remember, it is degree centigrade but not degree Kelvin, it is only Kelvin. Okay, so then the last concept that comes about your evaporation, the conversion of the liquid into gaseous state below its boiling point. So like you can say the water gets vaporized from the surface, so it's a surface phenomena, but boiling is a bulk phenomena. And there are a number of factors which affects the rate of evaporation, like there is temperature, there is a surface area, there is wind speed, and these are directly proportional to the rate of evaporation. But humidity, the amount of water vapor present in the air, that also affects the humidity. That's why in the case of winter season, when we have dry weather, although the temperature is not high, but the rate of evaporation is faster. But on a humid day, you may not find the rate of evaporation is fast, it is very slow. So on a hot and humid day, humid day particularly, you do sweat a lot, but the evaporation, the sweat is not getting evaporated. And evaporation also causes cooling, because if it is a surface phenomena, the particles on the surface absorbs heat from the surrounding layer, thereby lowering the temperature. Okay, so this is all about your chapter, and I am already I'll post now about the questions that has come in from this chapter. So you have to solve that one and post it my personal WhatsApp number. Then I will provide you the answer key for it, so that you can compare. But get ready with a pen and paper to write your answer. Thank you.